All right.
Hang on a second.
Timer. Welcome to our talk on practical deployment of MACsec. I'm Jessica Mann. I come from Field Application Engineering and Automotive Ethernet.
And I'm John Simon, Product and Applications Manager at Intrepid Control Systems for Automotive Ethernet products.
So we are a field application engineer and a product manager who for the last 7 years have been foundational contributors to Automotive Ethernet's widespread adoption. When MACsec entered the automotive industry, we began to observe developers run into real-world challenges as they began to explore the development process and integrating MACsec into future designs. Oh, and here's the clicker. So we'll discuss some of those challenges that MACsec brings to new automotive designs, generally around testing and deployment as well as whole vehicle lifecycle. And we'll do this while looking at TC17 and particularly what falls out of the scope of TC17 and is left to the developer. So MACsec was ratified in 2006, and after almost 20 years of adoption in other industries, it was automotive's turn. When developers gained access to the first products with MACsec, they discovered the challenges of interoperability, testing, and integrating MACsec due to the wide range of options that it offers. In addition to the assumptions that silicon vendors made when they designed their products, and the varying ways in which silicon vendors used to configure and deploy MACsec. So in other words, the early days of MACsec were like the Wild West, a term that's been used several times at this conference so far, to describe a chaotic environment lacking rules like automotive before standards created interoperable profiles. MACsec is a standard, but implementing MACsec without an automotive profile was like a game where no one knew the rules. Vendors had to support the entire MACsec standard in both hardware and software, and making their own assumptions along the way as to how it was going to be used. Developers then had to select compatible options to bring up a link. They had to get this to work between vendors, each vendor having their own configuration tools, software and APIs. And then the developers had to perform validation on all levels of the technology, and then again at the system level. In addition to this, without an automotive-specific MKA solution, they were going to have to create a proprietary key exchange mechanism in order to handle MKA meeting the automotive-specific challenges. In other words, successfully deploying MACsec goes way beyond simply selecting to use MACsec 802.1ae and 802.1x MKA from IEEE. And that's where TC17 comes in. Open's TC17 committee is determining how to apply MACsec and MKA to meet the automotive requirements that are unique to our industry. So while our industry has lots of automotive-specific requirements that make it unique, in the context of MACsec, this is generally around rapid startup time and taking advantage of the simplification that's offered by having a static network architecture. But in the meantime, product developers are growing anxious. And as a field application engineer, here are some of the questions that I found are on the minds of developers as they encounter MACsec. So for example, how is MACsec and MKA sourced? Do they come from the same vendor? If they come from different vendors, how do I make them work together? Is there a standard API library that helps make this possible? How do we store keys? Is the security of keys addressed in TC17? At what point should we distribute and use keys? Are there any best practices related to key distribution? Are there any legal requirements when I deploy MACsec in a vehicle that I need to be aware of? And in terms of integrating and testing, now that MACsec is on a link and we usually use these links to inject traffic and simulate networks, how is testing impacted by MACsec? How do we validate startup time now that we have to do MKA exchange before we can bring up a secured link? And there are so many questions. It's hard to know which questions are valid, which questions are of concern to you as a developer, if you're working with MACsec, and is TC17 going to address these questions, or are they left up to you as a developer making use of MACsec? So to put this into a single question, what does TC17 offer, and how do we implement MACsec effectively in light of TC17? So let's take a look at TC17's objectives. TC17 was established to meet the industry's desire for an interoperable Ethernet security protocol, and TC17 approaches this by adapting MACsec with three subgroups. So the first subgroup takes MACsec and creates an automotive-specific profile, simplifying interoperability for MACsec itself. A second subgroup works on modifying MKA key exchange in order to work in an automotive network and meet the automotive-specific requirements. Like we mentioned earlier, rapid startup time is critical for most automotive applications. And because MACsec was developed as a point-to-point security solution, and Automotive is adopting 10BASE-T1S, a multi-drop protocol, there's a third subcommittee looking at how to make use of MACsec on multi-drop protocols, with a lot of work ongoing. As of a few days ago, there was an open face-to-face meeting where TC17 voted on the proposal for MKA, and this will be brought to the Board of Directors at Open Alliance this month for ratification. And let's take a look at how testing is specified in TC17. TC17 does address 6 groups of test categories with the goal of further developing them into test specifications. So these specifications address interoperability and conformance, ensuring that all hardware and software works together, and that MACsec hardware and software can be used across vendors. But these are test specifications for conformance and compliance. They do not tell vendors how to test their systems, including testing their systems over the lifetime of the vehicle. So while TC17 provides a MACsec profile and MKA mechanism suitable for our industry, it's important to note what is outside of the scope of TC17. TC17 does not address how to distribute keys to ECUs. OEMs have different ways to do this, and this is outside of the scope of TC17. It doesn't address the testing of the key distribution or provisioning mechanism. It doesn't address how MACsec is integrated into the development process, and it doesn't address service considerations. So in other words, the MKA portion of MACsec takes over only after the pre-shared keys have been installed into an ECU, and it's from that point forth that the MKA server and client mechanism take over to distribute the session keys and bring up a link. So to take a further look at the development strategy, John Simon will lead us through his views of development.
So how's this going to work to roll out? What would be the ideal MACsec deployment strategy? Like most questions in engineering, it depends. But one thing that for certain, it needs to align with your product development process. But beyond that, there's some differing opinions. If you're responsible for the entirety of the security of the vehicle, you would want to roll out everything related to MACsec as early as possible to get the widest test coverage and the widest number of samples. And when I say full MACsec, I mean MACsec, authentication, and MKA, and the production intent process of provisioning and securely installing keys. From a developer's perspective, this is the biggest impact to network development since we moved from CAN to Automotive Ethernet. And when I say big impact, that's the anvil coming down on the developer there. So they're faced with a steep learning curve, new tools, new processes, and so from their perspective, this is going to impede their ability to meet the product development schedules. So there's got to be some sort of compromise. Another consideration with this deployment is how it's introduced. So I would describe this as a big bang introduction, where you basically drop MACsec into the program. And Big Bang, just the name itself, it's not a very good strategy or plan if it's a plan at all. What you want to do is approach it incrementally. So you start with a static SA key or session keys. Then there's a mode that TC17 made provisions for where you can enable MACsec and MKA, but disable the actual authentication or encryption. Then when you actually turn on the authentication or encryption, you're working with secret keys. There could be a period where you're working with the secret keys, but they're not really secure, and I'll explain that in a future slide. Then you move to a secure deployment and installation of keys, and then ultimately, provisioning. So if this seems like a reasonable outline, I'm going to go into each one of these in a little more detail and talk about the impacts of development and testing. In the early development, when you get your first hardware, you're bringing up the hardware. You don't necessarily have an MKA stack. You don't necessarily have any application software. So you're writing drivers and testing the drivers, the ability to configure the PHY, install the keys, and you can do the most basic level of interoperability testing, much like the first plug fest for TC17. And the way this works in a media converter, so you have an interface from your laptop or test equipment, and you install the static key over USB or some other interface. It installs it into the PHY. There's more than one way to implement MACsec in testing. So obviously, if you use a automotive PHY that's got the IP integrated, that's primary option. You can also use Linux. It's got support in software, which will also work. You just need to be concerned if you're approaching gigabit link speeds about the performance. It's going to depend on the hardware platform that you're using. The next logical step would be to enable MK and MACsec, but not enable authentication and or encryption. So the advantages of this are you're introducing the latencies associated with key exchange. You're testing the MKA's stacks on all the devices out in the field. It's a minimal impact to product development. You're also inserting the additional sec tag information, so you have the longer frames and any implications associated with that. So the way this works is there's a full key exchange. After the keys exchange, it's sent to the key is decrypted and then installed into the PHY. The PHY is inserting sec tags and ICVs, but beyond that, they're not being used for anything. So the cons for this are you're not testing the entire system. At a low level, you're not testing the key installation. You're not testing the key rotation, the successful key rotation. You're not testing the replay attack mitigation. And then you're also not testing the PHY's ability to insert sec tags and properly process them. The other thing is this is a potential attack surface, so it would need some sort of, it would need to be removed, or it would need to be blocked or restricted once you get to production. Then we get to using secure keys, and this would be a point where you may not be able to ensure the security of the key. And so what I mean by that is if you're using a laptop or most test equipment, these devices can't secure keys to the extent that an embedded system can with the hardware security module. So the keys in RAM or in the file system, it's vulnerable. But during this case, key distribution is very simple. You still have all the MKA latencies, and you have the additional test coverage of the low-level PHY operations. The cons here, with this dramatic foreshadowing, so all these cars, if you don't test or exercise the provisioning and secure deployment of keys, if you don't test installation of the keys into the modules in a production environment over and over and over, and you have a hiccup in production, you're going to be building cars and then promptly parking them until you get it resolved. So once you move to a fully provisioned and secure deployment system, as a tool supplier, it's not clear to me what will be needed in tools. Is there a need, or will there be a need for tools to have secure storage of the keys, either pre-production, post-production, in the field, and then maybe a right to repair scenario? And at this point, once you're interfacing or able to interface with the ECU or a vehicle with secured keys, that's by definition a security vulnerability. So we already talked about disabling MACsec. Another option would be to deploy a new temporary CAK. If the keys are stored on a server, possibly securely retrieving them, or, like I said, is there a need for secure storage in tools? And in all these cases, it's a matter of managing risk. So you're faced with looking at an unacceptable risk and then trying to balance it with adding complexity in the form of defense in depth or other measures and money, and then you're trying to find a balance between the risk, the complexity, and the cost. In the case of the secure keys being stored on a server, if this was an option, the pros are there's probably existing infrastructure for this, for SecOc and possibly other vehicle information that's needed in today's production. The cons, again, the minute you download that key into the laptop or equipment, it's no longer secure. So it's vulnerable in RAM. You can't save it, and it's not persistent. You can't save it in the file system. And you might want a persistent network connection with the server just to verify that at the end of whatever diagnostic session, the key's erased from memory and it has not been compromised. The other consideration is now you have IT involved. So for every tool chain, every tool supplier, you need to work with IT to have server access and manage that access. So what would be, I was trying to think of what would alternatives be and what complexities could we remove. So the goals would be, can we have a secure key in hardware, persistent, without a persistent network connection, and something kind of key deployment that doesn't necessarily involve IT. But this also introduces some complexity because now if you're securing the key in the hardware is not necessarily secure, so you would probably need some level of user authentication to make sure that if a tool was stolen, it wouldn't be used unauthorized. So I have a few ideas. Again, last night I used the term spitballing. It's really brainstorming. I'd like to present these to you for consideration. If you wanted to add secure storage to a laptop, the first thing that comes to mind is a USB key. Some sort of HSM in a USB. It's nothing new. It's been used for decades. But the downside of that is it's another device that needs to be protected. And all of the data being exchanged between the key and the PHYs exposed in RAM. So the unencrypted session keys would be exposed. So I had the thought, what if you put an HSM in a media converter? And the way this would work is the CAK would be securely stored in an HSM. The MKA stack would pass over the MKPDUs to the media converter for authentication, and then assuming everything's authenticated, when a encrypted key is received, it passes the encrypted key over for secure installation into the PHY. So at no point are any of the keys exposed outside of the media converter. Again, all of these, once you're installing the key in a device, you need to somehow have some authentication to prevent unauthorized use. This is a derivative of this. I hesitate to call it a media converter, but because of the system on chip between the two PHYs. But this idea came to me from my experiences when GPTP was being more prevalent. So there would be test equipment, and it didn't support GPTP, and they needed to support test devices that don't work without it. So in that case, in most cases, we just put a switch in between, and it was fine. So it's basically bringing legacy hardware up to be able to test the newer hardware. In this case, with the system on a chip, you have a little more freedom. The system on chip can keep the base T link down to the rest of the test environment until there's a secure key exchange. And yeah, you can also implement this with a switch or with or without the HSM. And then I want to talk briefly about active taps. They're not used as much as media converters, but one thing that people don't always consider is just because you're using MACsec, with an active tap, you don't necessarily need any MACsec support. If you're not using encryption, the data's visible, you don't need MACsec. If you don't need to transmit authenticated messages, you don't need MACsec. If you don't need to authenticate messages, you don't need MACsec. So in many cases, it's not something necessary. When you need it would be if like a man in the middle, an actual man in the middle scenario where fault testing, injecting data, or debugging MACsec. You can also parallel test devices in parallel. And so the way this would work is embedded MKA stack with a unique session between each one of the ECUs. Before we get to takeaways and discussions, you might ask the question, well, why didn't I present this to TC17? Well, I had a brief discussion with Oliver on Tuesday, and we both agree that we don't think we're getting the right participation in TC17 to allow it to move at the pace it needs to. So I thought I'd take this opportunity to present this to a wider audience, maybe get some people interested that didn't know they should be interested for further participation. I'm getting this question a lot. Does a tool support TC17? There's two problems with this question. One, the word support is rarely well defined or understood by the person that's asking it. And the second one is they expect a yes/no answer. And I put this question in the same category as, does this hardware support TSN, or does this software support GPTP? It depends. And so part of this is due to the learning curve of people that aren't writing the specs, that need to pick up the specs and do development. So in the meantime, if they can't define support, can we do that for them? What's the tool purpose? Does it need to be transparent? Are you testing, debugging MACsec? Is there a value in having a standard PHY interface? Does the use case need an embedded MKA stack? And then again, key storage. We can do it. That doesn't mean it's needed, but so that's a question to all our customers to tell me what they think of this. And this is the broader question is there a need for tool profiles and standardized interfaces? For the benefit of product developers, we need to close the gap between the spec authors and the product developers. In MACsec training, I do a lot of ad hoc training, as Jessica does, in small groups, but if it's so much more efficient if it's driven from the top down. And the workshop that was at AEC, I thought that was incredible. I think something like that or a derivative of that would be good for any OEM or Tier 1 to the people that don't have the luxury or the benefit of attending these conferences. Understand the deliverables of TC17. And then also comprehend what is not specified in TC17 and come up with a plan for deployment. So that involves some sort of phased deployment. It's not necessarily what I had, but again, I'm just brainstorming through this. Training, plan for defining best practices and communicating those, and then tools development. Are the tools available, or will they be available with the features that you need when you need them? It's very difficult for us to design tools in parallel with your designing of ECUs.
And while we just looked at the development process and tools involved in the development process, we also have to take a look at service in the entire vehicle lifetime. As a developer, you must also consider the whole vehicle lifetime when implementing MACsec, and this means we have to mention service. So if I were to say replacing an ECU should be as easy as replacing a tire, is that a realistic goal? And while you may roll your eyes at that, in many places, there is a strong culture of people working on their own cars. In America, for example, we take great pride in an American car culture, and many cars have gone on to be iconic symbols of our culture and our land. There are even places where right to repair is being legislated. And don't forget, we want our automotive history preserved for future generations. Even long after key provisioning servers have been decommissioned by OEMs. TC17 does not address how keys are distributed, and so we think this is a case where an industry best practice should be considered. A best practice would function to create a somewhat uniform way in which key provisioning is handled in the industry, while leaving it up to OEMs to figure out the exact details. And consider how this has been addressed in other industries and other products that are used in cars that are maintained on an occasional basis. So I would give the example of tire pressure monitoring systems. The method of repairing and reprovisioning a new TPMS sensor is relatively the same for all cars out there right now. And it allows for development of service hardware that's able to address this across multiple car brands in the industry. And yet, in the case of MACsec, we do have to balance this with safety and security. And while we don't have an answer, we think that this risk is universally shared, and if the risk is universally shared, why not share the cost and balance and complexity of forming a best practice? And we'll take questions.
All right. Thank you, Jessica. I don't have the mic anymore. John's got the mic. Thank you very much for the presentation, and we will open it up to questions too. Here we go.
Not so much a question, but first a big thanks for an excellent presentation. You did good justice to what TC17 is right now, so thank you for making this in this event, in this forum. So for me, it is a reasonable request to discuss this openly, if this should be actually part of TC17, right? So there are other standards out there that talk more actively about key distribution schemes and have some notion of how to do this. And we have been debating this in the beginning also of TC17. Is this something we should be doing quicker, or is this something we should keep out of scope because we are more leaning towards finding it in a different forum maybe, that we can borrow from a different technology what we should be doing? So for me, it's an excellent question, right? So the key distribution and management, especially when you talk about the long-term effects and historical vehicles, ultimately it would be ideal if we had something like a foundation that would enable to take over the responsibility of being the secure trust center for such out-of-service vehicles, right? So at some point we need to talk about whose responsibility are the security updates of vehicles when they are basically out of lifetime from the perspective of an OEM. So I was wondering if you had some initial thoughts on where you would see this going.
Yep. Okay, so to start with that, there would be the assumption that keys are provisioned by an OEM and held in a database. And from that point of view, you would have to figure out what to do when the database is decommissioned. And you'd also, if you were cared about right to repair and car culture in the meantime, you'd have to figure out how someone could retrieve keys and reprovision their vehicle. If that wasn't the case, then you would have to design a system where vehicles provision themselves with randomized keys. And at some point in time, you would decide that the vehicle network was secure. There were no man-in-the-middles in the vehicle, and you would have the vehicle reprovision new randomized keys and distribute keys in the vehicle in a safe environment, save them, and move forward. And there might be a point in time where there's a reason to have keys stored in an OEM and be non-serviceable to interact with outside services, and then at some point in time in the future, allow the vehicle to provision itself and give up that root of trust to the outside world.
Thank you, Jessica. Thank you, John. What educational resources do you recommend so I can learn more?
He might be standing right behind you. No, like I said, there was a workshop. If that could be, I don't know, scaled towards maybe deployment in different venue or different audience. And as far as resources, yeah, I think it's mainly the presentation material that has been floating around for the last several years. The specs are hard to read. I don't know if you noticed that. So yeah, but there is an education, it's not a committee for open that hasn't really got much momentum. And so, that might be one of the first tasks or assignments. If we can get some momentum right now, there isn't any, so.
Thank you.
Hi. Have you considered the way that we do the key provisioning in ASA? Because that was basically what Harry and I used as a solution for, it's on the roadmap for like the TC17, right? That's what we want to base the, one of the possibilities where you want to base the key provisioning on. Have you looked into that?
I have not. I will definitely take a look at
because
that.
I think one of the last questions you were asking, there's already stuff we defined and it's on the roadmap, but we just pulled it out of scope until version 2. And as Oliver just said, like yesterday, the version 1 is basically pretty much finished, so that's like the next step anyhow.
Okay. Yeah, thanks.
Okay. Yeah. Well, I'm not sure if I can talk that loud. But no, the mic doesn't work, I think.
No, it's working.
It is? Oh, I have to be very close? Last time you told me like this one. Okay. So TC17 has an automotive MKA group. And in that, we said in the version 1, we do key exchange. Key provisioning and shared medium optimizations are for version 2. And that is starting like later this quarter. And then you will get a solution. And one of the ideas what to base it on is the ASA key provisioning and key management standard. Because we built a similar thing like 2 years ago already. So there's something out there. And I think the microphone has to be set up in a different way. No, that's a current proposal is this ASA solution to take that as kind of a blueprint to see if parts of that could be reused or something similar being developed.
Anyone else?
It's lunchtime.
Yeah, we're holding up lunch.
Yeah.
All right.
All right.
So.
Great. Thank you.
Thank you.